Alright, ready. Today we are starting with page 98. But before we start, let's take a quick revision about what we have already studied. So we started first speaking about our planet Earth and our solar system. We spoke about how the sun is our medium star. It's considered to be a medium star, yet it's very, very huge compared to our own planet. The sun gives us heat and light, and the sun alone contains 99.8% of the total mass of our solar system. The temperature of the surface of the sun is very, very high compared to the light and heat that comes to us, approximately 10,000 Fahrenheit or 5,558 degrees Celsius. Our solar system consists of the sun and 8 planets. Those 8 planets are orbiting the sun in a very strict way. There are some asteroids and comets that penetrate our planet Earth, and likely most of them burn out before they hit the
Hello?
surface. Yes, we can hear you now.
Oh, okay, that's good.
Okay, so regarding to the light year, we have spoken about why do we use it, as there are some planets or some meteorites, stars very, very far away from our own solar system, and we cannot measure the distance using kilometers. So simply we use the light. Later we have spoke about the Earth's movement, and we said that the slope of the Earth's axis enables us to have a day and night, and the orbit of the sun is not a circular one, it's an oval one that gives us the full season. And we knew now why there is unequal length of day and light on some parts of our planet, and this is because the axis is in a slope of 23.5 degrees. We have also spoken about the theories of our planet structure, that some scientists thought at first our whole planet was nothing but full of lava, and later on some materials and minerals were pushed out to the crust of our planet, and they were golden, and later the main 4 layers have already been constructed on the planet. The last thing that we have studied is the main subsystems of our planet Earth, and we said that we have the mantle, we have the core, we have the atmosphere, hydrosphere, biosphere, and lithosphere. All of these subsystems enable us now to live in peaceful and in a very good place. So, in today's session, we will start by just having the relation between those subsystems. What do you think the relation between those subsystems is? How can we connect all of these subsystems together? Hello? Grade 8? Did you buy or something? How can we connect the subsystems of our planet together? Can you hear me at least, please?
Yes, teacher.
Right. So the diagram in front of you now shows you how the complex relationship between the Earth and subsystems are happening. The first subsystem we have is our atmosphere. The atmosphere simply contains the gases on our planet Earth. We have the hydrosphere. In that place of the atmosphere is the hydrosphere one. We have the lithosphere, we have the biosphere, and we have the mantle and the core. So simply, when you have an ocean or something, okay, light and the heat from the sun come and hits the water, and the water evaporates into the hydrosphere one. Of course, the hydrosphere is being included into the atmosphere, and because of the atmosphere, so it will move the hydrosphere system from one place to another, and this is because of the wind. When it hits something with a very differentiation in the temperature itself, water and rain happens. Later we have the biosphere, when you have a river, and consequently you will have some farming. Besides that, that's our biosphere. When you have the desert and the plain where there is no water or there is drought for many years, you will have the lithosphere one. According to the mantle, it tells us about the surface of the earth and the layer beneath it, and the core, of course, of our planet contains the molten lava that is impossible to anyone to reach. So simply this diagram shows us how our whole subsystem on the planet works together in a very precise way. What about the seasons? We have already spoken about the season, and the only main reason for seasons to happen is that the orbit of our planet Earth is not circular one; it's an oval one, in the shape of an oval. So for some places on our orbit, the Earth is going to be very close to the Sun. Yet on other places on the orbit itself, the Earth is going to be very far. When the Earth is so hot, so near from the Sun, so consequently summer happens for the place that faces the Sun, and the other side that there is no Sun, which is the other side of the Earth or the other hemisphere. So this will be winter. When it's very away, you will have the winter, and the other side will be summer, and you have the four seasons.
The seasons. All the planets in the solar system move in orbit around the Sun. This diagram shows the Earth's orbit around the Sun. Because the Earth is tilted on its axis, one side of the planet is always tipped away from the Sun, and the other side is tipped towards it. Because of this orbit, some parts of the Earth receive more sunlight than others at different times of year. This causes the seasons. Equinoxes and solstices. The word equinox comes from the Latin word meaning equal night. On the 21st of March and the 23rd of September each year, the two sides of the Earth have days and nights of equal length. The solstices are on the 21st of June and the 21st of December. On the 21st of June, the Northern Hemisphere has its longest day and shortest night of the year, while the Southern Hemisphere has its shortest day and longest night. On the 21st of December, it's the other way round, the shortest day in the north and the longest day in the south.
Alright, so the only reason for the differentiation in our seasons, we have winter, we have summer, we have autumn, and we have also spring. All of them happen due to the oval orbit of the Earth, and that at some places of that orbit you found the planet Earth is so close to the Sun, yet at other places of that orbit it will be very far from the Sun. Right, this is causing the four main seasons, and of course because the Earth itself is titled in a slope of 23.5 degrees to its axis. So this differentiation happened between the northern hemisphere and the southern hemisphere. And the equinoxes and solstices, simply because of this unequal orbit, and also because of that the Earth is tilted on its axis. Okay, you will find that at some specific days, which are 21st of March and 23rd of September, each year of the two sides of our planet Earth have days and nights of equal length. And so the only way you will have 12 hours day and 12 hours night. So only on those days. And you will have also on the 21st of December and the 21st of June, you will have the northern hemisphere, the longest day and the shortest night, and the southern hemisphere will have the vice versa, or the opposite. Any questions so far? Why do I feel like that you are late today? Hello, anyone? Any question? Can you hear me at least? Hello?
Yes, teacher.
So once again, we have spoken about the seasons. So let's move to page number 101.
If you look at the position of the Earth on the 21st of June, you will notice the following. The northern hemisphere is tilted towards the sun. As a result of this, the northern hemisphere receives more hours of sunlight than the southern hemisphere. In the north, this is midsummer, and in the south, it is midwinter. The place that receives the most direct sunlight on this day is the Tropic of Cancer. People at the equator experience a day and night of equal lengths. People in the northern hemisphere have a very long day and a very short night. People in the southern hemisphere have a very long night and a very short day. In the area between the Antarctic Circle and the South Pole, there are 24 hours of night because the sun doesn't rise. In the area between the Arctic Circle and the North Pole, there are 24 hours of daylight because the sun doesn't set. Activity. Explain what would be happening in each hemisphere on the 21st of December.
So if you can look to the diagram right here, this explains to us the whole idea. So here you have the sun and you have the planet Earth. Most of the sun rays now, because of that the Earth is tilted to its axis. So if you can see from here until this area, all of this area are in the sunlight. So the northern pole, all of it is covered with the sun. So for all of the day, it will be 24 hours, it will be sun. And vice versa, when the other season happen in winter, on the 21st of December, you will find the whole of the northern hemisphere, or most of the northern hemisphere, and the whole of the North Pole is covered in shade. So for 24 hours, it will be shade. There is no sun, and vice versa to the southern pole or the south. Okay, and all of this happened only because the Earth is titled to its axis, and this is what causes the differentiation in the day and night hours. If you can see the equator here, It has an equator. Do you have a problem seeing my screen, guys?
We can hear you, teacher.
Can you see my screen?
Yes. We can see your screen.
So you can see my screen.
Yes.
Okay.
I can see it, teacher.
There anyone who cannot see my screen?
I can see.
Okay. Anyone cannot see my screen? Mr. Abdul, do you have a problem seeing my screen?
Yes, Mr. Ahmed, good morning. The material you are talking about is not displayed on this.
Okay, just hold on a moment. I'll just stop sharing and share again, and you
Yeah,
try
maybe
to do the same,
maybe
please.
technical problem.
Okay, you just try to look out and look in a game. This happens when some students do not see. I stopped sharing. I'll share again now.
Yeah, please.
Is it loading now? I believe now you can see it.
Still no.
I can. I can, teacher.
Please try to look out and look in again.
I can see it, teacher.
Okay, Muhammad, this happens because of a technical problem. He will just join us in a moment. Now you can see it, Mr. Abdul.
Yes, now I see your screen, but yeah, start seeing the icons on your desktop. Yes, now it is displayed. Now it is displayed.
So it was just a technical problem from Medina. No problem.
Maybe a technical problem related with
It happened a lot.
now it's okay.
Okay, so once again, guys, we were speaking about the seasons and how the seasons are different from one place on our planet Earth regarding to two things. The first thing is the orbit of our planet Earth itself around the sun. As you can see in this diagram, the orbit itself is an oval one, not circular one. This is very important. The orbit of the sun is oval. The second thing is that the Earth is tilted on its axis on 23.5 degrees, and this causes differentiation in the hours of the day regarding to the hours of the night. When we speak about the 21st of June and 21st of December, on the 21st of June, you will find out that most of the northern hemisphere is in the sunlight. On the other hand, most of the southern hemisphere is in the shade. So, for example, you have the North Pole, you have the Arctic Circle, you have the tropical Cancer. Most of them right now are in the sun. For the North Pole, most of the sun rays hit the whole of the North Pole. This will result in a 24-hour light day. So the whole day for 24 hours will be in the sun rays. So you don't have night at that place. On the other hand, on the 21st of June and the South Pole, all of the South Pole right now, because of Earth is tilted around its axis with that slope, okay? So all of it right now is in the shade. No sun rays reach that place, resulting in a 24 hours dark day. So all of the day will be in the dark. This is, of course, the vice versa or the opposite of the 21st of December. On the 21st of December, the southern hemisphere faces the sun and the northern hemisphere faces the shade. So we will have the 24 hours day in the south pole. All the day will be in the sun rays, so all of it will be light, and On the other hand, the northern pole will be dark for 24 hours. So the operation is inverted from 21st of June and 21st of December, and the main reason for that is because Earth is tilted around its axis. If I ask you why we have a 24 hours day, yeah, on 21st of June on the northern pole, and the same question, why do we have 24 hours shade in the northern pole and 21st of December? So it's the same answer, because Earth is tilted on its axis. Again, because Earth is tilted on its axis. And as you can see here, if we look to the position of the Earth on the 21st, you will understand the whole idea. So we have here the Arctic Circle, the tropical Cancer, the equator, the Capricorn, the Arctic Circle, and the South. All of them right now have different places on the sun rays, except for the equator. For both 21st of June and 21st of December, the equator is exactly in the middle of the sun ray and the shade. So we have 12 hours on that place of day and 12 hours of night. So an equal day and equal night on 21st of June and 21st of December on the equator. Any questions so far? Any questions so far to date?
No, teacher.
No, teacher.
Let's watch this video.
You know that Earth orbits the sun, right? And that it takes a full year for our planet to complete its orbit. Earth also rotates like a slightly tilted spinning top. Earth remains tilted in the same direction all year round as we orbit the sun. But that means the sun's light shines differently on Earth at different times of the year. Let's look at Earth when it's winter in the northern hemisphere. Observe how the North Pole tips away from the sun. This means that sunlight strikes the northern hemisphere at a shallow angle for a short period of time. This is why winter weather is generally cool, with short days and long nights. As Earth orbits the sun, we move towards spring in the northern hemisphere. Now Earth is tilted neither toward nor away from the sun, as day and night are about equal in length. As we make our way to the summer months, notice that Earth is still tilted in the same direction, only now on the other side of our orbit. The North Pole is tipping toward the sun. Sunlight strikes the northern hemisphere more directly, and the sun stays in the sky for a longer time. Compared to winter, summer days are warmer, and the sun stays in the sky much longer. Notice too that while it's summer in the northern hemisphere, it's winter in the southern hemisphere. Because of Earth's tilt, the seasons are reversed. We observed how Earth's tilt creates the different seasons throughout the year. How does this affect life? Plant life and other photosynthesizers, we call them primary producers, depend on sunlight. They respond to the changes in the seasons. Earth-orbiting satellites measure the amount of carbon dioxide absorbed by these primary producers. Bright regions on this map show where they devour the most carbon dioxide, turning light from the sun into oxygen and natural sugars. In spring, when sunshine strikes the cold waters of the North Pacific, productivity skyrockets. Phytoplankton and other microscopic photosynthesizers form the base of the ocean food web, and all ocean life responds to changes in the seasons. On land, forests grow green during the spring, brightening the continents. During winter, continents in this view turn dark from a lack of photosynthesis.
So again, I need you to notice how Earth moves in our orbit around the sun.
You know that Earth orbits the sun, right? And that it takes a full year for our planet to complete its orbit. Earth also rotates like a slightly tilted spinning top. Earth remains tilted in the same direction all year round as we orbit.
So this is the axis. Of course, it's an imaginary one, the axis of the Earth. Okay, and the Earth orbits around itself around that axis. Okay, and it's tilted, meaning that with a slope.
The sun. But that means the sun's light shines differently on Earth at different times of the year. Let's look at Earth when it's winter in the northern hemisphere. Oops.
So you can see that the northern hemisphere absorbs a little amount of the sunshades of the sun rays. Consequently, winter happens. On the other hand, in the southern hemisphere, a lot of place because of the axis now. See, that's the imaginary axis of the planet Earth. So most of it is in the sun rays position. Consequently, summer happens in the southern
Observe
hemisphere.
how the North Pole tips away from the sun. This means that sunlight strikes the northern hemisphere at a shallow angle for a short period of time. This is why winter weather is generally cool with short days and long nights. As Earth orbits the sun, we move towards spring in the northern hemisphere. Now Earth is tilted neither toward nor away from the sun, as day and night are about equal in length. As we make our way to the summer months, notice that Earth is still tilted in the same direction, only now on the other side of our orbit. The North Pole is tipping toward the sun. Sunlight strikes the northern hemisphere more directly, and the sun stays in the sky for a longer time. Compared to winter, summer days are warmer, and the sun stays in the sky much longer. Notice too that while it's summer in the northern hemisphere, it's winter in the southern hemisphere. Because of Earth's tilt, the seasons are reversed. We observed how Earth's tilt creates the different seasons throughout the year. How does this affect life? Plant life and other photosynthesizers, we call them primary producers, depend on sunlight. They respond to the changes in the seasons. Earth-orbiting satellites measure the amount of carbon dioxide absorbed by these primary producers. Bright regions on this map show where they devour the most carbon dioxide, turning light from the sun into oxygen and natural sugars. In spring, when sunshine strikes the cold waters of the North Pacific, productivity skyrockets. Phytoplankton and other microscopic photosynthesizers form the base of the ocean food web, and all ocean life responds to changes in the seasons. On land, forests grow green during the spring, brightening the continents. During winter, continents in this view turn dark from a lack of photosynthesis.
I hope that we now have a very clear image about how season works and why there is a differentiation between the temperature and the season on our planet. Any questions so far, grade 8?
No, teacher. Goodbye.